Alright, ladies and gentlemen, as promised, I said I'd put together a video that would cover the major concepts for your summative tomorrow in fractions. So I'm going to go through some sample questions in this video and talk about procedure and the way that you would want to attack those styles of questions. If you would like to work on the sample questions you're about to see independently prior to seeing the solutions, you could pause the video and work through the questions on your own, and then continue to play the video to see the solutions and see how you matched up against those. So for the first objective, we're going to look at missing values in equivalent fractions. As you can see, one of the values in the equivalent fraction pairs is missing, and as we talked about in class, what we want to do is we want to travel towards the unknown value. So if we look at the first pair, we have 2/5 is equal to something over 15. So we need to be traveling in this direction to find the unknown value. So we would look at the pairs of values that are together, 5 and 15 for example. We'd look at how many 5s we would need to make 15, and we know that would be 3. So whatever we do to the denominator, we would also need to do to the numerator. So it would be 2 times 3, which would give us 6. Similar to that, looking at the second example, we have 5/6 equals something over 24. Traveling to the unknown. How many 6's make 24? Well, we need 4 of those, so we'd multiply by 4. So we'd also do the same to the 5. We'd have 5 times 4, giving us 20. Now in the third example, it's slightly different in that as we travel to the unknown, we may notice that the pair of values are diminishing or getting smaller. That would be an indication that we are dividing. And this time, 9 becoming 1, we would divide by 9. So we'd also take 27 and divide by 9, which would give us 3. For our second objective, we're looking at adding and subtracting fractions, so a few rules to stick with, and that is: 1, we must have a common denominator, and that is the value on the bottom of the fractional pairs. And when we add and subtract fractions, we add or subtract only the numerators, not the denominators. So as we look to our first example here, we have 3/8 plus 1/4. 8 and 4 are not the same denominator, so as a general rule, we'd want to see if we can multiply the smaller of the two values, the 4, to make it the same as 8, and we should know that we can multiply that by 2. So to create that equivalent fraction, we must also multiply the numerator by the same number. Okay. At this point, we would rewrite our number sentence to give us 3/8 plus 2/8, and now that the denominator is the same, that would simply go to the answer as 8. And then 3 plus 2 in the numerators will give us 5/8. This would be representative of our entry-level style of question, where we have to change the smaller of the two denominators to become the same as the larger value in the denominators. As we look at the next two examples, we have a value in this one, 5/9 plus 1/6. 9 and 6 are not the same. And in order to find a common denominator, we're going to look at the multiples of 9 and 6 to find the first one that they have in common. And in this case, it would be 18. So we would need 2 groups of 9 to make 18. We'll also do that to the numerator. And we would need 3 groups of 6 to make 18. And we will also do that to the numerator. We will rewrite the number sentence to give us 10 over 9. Oh, sorry, 10 over 18, my apologies, plus 3 over 18. 18 is the common denominator, it will go to the answer, and simply 10 plus 3 is 13. Okay. For our third example, 5/6 plus 3/4, we're looking for a common denominator for 6 and 4. First common multiple that they have is 12. So we need 2 groups of 6. 3 groups of 4. Rewriting the number sentence, we would have 10 over 12 plus 9 over 12. And what we're going to notice here when we add these two fractions, now they have a denominator of 12, 10 plus 9 gives us 19. 19 over 12 is a representation of an improper fraction where the numerator is larger than the denominator. In this case, we have to switch this to a mixed number. Remember, the numerator represents the parts that we have, and the denominator represents the parts in a whole. So in this case, 12 could go into 19 once, so we could fill one box with 12 items. And then when we remove those 12 to fill up that one box, we would be left with 7 leftover parts. The 7 would go to the numerator, and the denominator would remain at 12. Looking at a couple subtraction examples here, the same rules apply. 9/10 take away 1/5. 10 and 5 are not common denominators, so the smaller value 5 we could multiply by 2 to make it 10. And rewriting that sentence, we would have 9/10 subtract 2/10 with a common denominator of 10. 9 subtract 2 in the numerators is simply 7/10. And 3/4 take away 2/3, 4 and 3, not a common denominator. 3 cannot go into 4 evenly, so we cannot use 4 as a denominator, so we're looking for a common multiple of 4 and 3. That would be 12. So we'd multiply this by 3 and multiply this by 4. Rewriting our number sentence, we would have 9/12 subtract 8/12. Common denominator of 12 goes to the answer, and 9 take away 8 is simply 1/12. Looking at the addition and subtraction of mixed numbers, now be aware this is an objective only for those on the standard or regular or grade level program. This is not an objective for those that are on a modified or entry level program. Okay? The same rules apply. When adding mixed numbers, in the fractional amounts, we need to have a common denominator. Okay? So in this case, we have 2 1/4 plus 5 7/8. 4 and 8, not a common denominator. We can multiply this by 2 and this by 2 to make it 8. That would leave us with 2 and 2/8 plus 5 7/8. In this case, at this point, we can now add our whole numbers. 2 plus 5 giving us 7. And in the fractional amounts, 2 plus 7 gives us 9 over 8. Please be aware that in the fractional amount, if we have an improper fraction, we must convert that. So in this case, we need 8 parts to make a whole, and we have 9, so we could make 1 additional whole. We need to remember to add that to the existing whole numbers of 7, so we now have 8 whole, and 1 part would be remaining. So we would have 8 and 1/8. Now I provided 2 subtraction examples here. Again, we need a common denominator. So 5 and 10, I would multiply this by 2 and by 2, and that would give us 7 and 8/10 subtract 2 and 3/10. In this case, there's nothing special that needs to occur. We're familiar with some scenarios where we might have to use one of our additional strategies, and we'll see that in our final example. But in this case, as we look to the fractional amounts, we have 8 subtract 3 in the fractional portions, which we can do. We can take 3 parts from 8 parts. So in this case, in the fractional section, 8 take away 3 is 5, and 7 take away 2 in the whole numbers is also 5. So we'd have 5 and 5/10. Now hopefully at this point you realize that in the fractional portion, 5/10, that can be reduced to simpler form, or simplest terms. So we're looking for a common divisor of 5 and 10. We could divide both values by 5, giving us the best answer of 5 and 1/2. Now for our final question, again, we have 6 1/3, take away 1 3/4. Common denominator for 3 and 4 would be 12. So I'll multiply by 4, and by 4, and then multiply by 3, and by 3. That would give us 6 4/12, subtract 1 9/12. Now this is where we hopefully notice something that will require us to use one of our alternative strategies. In the fractional portion, we would have 4 subtract 9. We cannot take away 9 parts if we only have 4 parts. So using the borrowing strategy, I can deconstruct one of the whole numbers that I have here. So instead of having 6 whole, I'm going to only have 5 whole. And when I deconstruct that, I would receive 12 parts, the number that's represented in the denominator. So I would have the 12 that I've deconstructed from the whole, plus the 4 that I already had, giving me 16 parts over 12. Subtract 1 9/12. Now, as we look at the numerators, we notice we could conduct 16 subtract 9, or taking away 9 from 16. That would actually leave us with 7 over 12, and then in the whole numbers, 5 subtract 1 would simply be 4. Now looking at the two strategies to convert numbers, converting first improper to mixed and mixed to improper, remembering what we mentioned earlier, the numerator represents the parts we have, and the denominator represents the parts in a whole. So we'd have 9/4, 9/4, meaning we have 9 parts and we need 4 to fill a hole or fill a box, or however you want to conceptualize that. So with the 9 parts I have, I can fill 2 boxes of 4, so I'd have 2 full boxes. And then using those 2 4s, that would be 8 parts that I would remove, and I would have 1 part left over, so I'd have 2 1/4. Similar here, I now have 12/5. I have 12 parts, and I need 5 parts to fill a hole. So from the 12 parts, I can fill 2 boxes of 5. That would require 10 parts. If I subtract those 10 parts from the 12 that I have 2 remaining. So 2 2/5. And this may come to pass. In this example, we have 36 over 9. We have 36 parts. They have to go in groups of 9 to fill a hole. And this may happen where 9 can go into 36 4 times exactly. So if I filled 4 boxes or 4 whole, that would be 36, and I would have none remaining. So there's no fractional portion here. Okay. Looking at converting mixed numbers to improper, remember, the whole number represents how many whole we have. The denominator represents how many parts are in each of those whole. So we would have basically 3 groups of 2, which would be 6, plus 1 extra part, which would be 7 over 2. The denominator doesn't change. Whatever the denominator is in the fractional portion of the mixed number becomes the denominator as part of the improper fraction. Okay? We have 4 2/5, so we have 4 whole with 5 in each. So essentially I'm doing 4 groups of 5, which would be 20. Plus I'll add the extra 2 parts, giving me 22 over 5. And for our last example, 9 1/8, we have 9 full boxes with 8 parts each. So that would give us 72. Plus the 1 extra would give us 73 over 8. And last but not least, we have reducing fractions. Reducing fractions is also called putting in simplest form or simplest terms. We have to remember our divisibility rules. The most essential and basic of those rules is that all even numbers can be divided by 2. And it's a great starting point for people looking to reduce fractions or to identify if fractions can be reduced. So in this case, we have 8/10. Knowing that they're both even numbers, 8 and 10 are both even numbers, we could divide both of those values by 2. Dividing by 2 is also easily referenced as cutting a number in half. So half of 8 would be 4, and half of 10 would be 5. Sometimes people are questioning whether a number can be further reduced. We remember that if the numerator and denominator are consecutive, and 4 and 5 are consecutive numbers, that fraction can't be reduced any further. There are some other rules. If your denominator is a prime number, the fraction can't be reduced. If the numerator is a prime number, it must be able to divide evenly into the denominator. Okay? Now, as we look at our second example, we have 6 and 15. Now, in this case, the numerator, 6, is even, but the denominator is odd at 15. So, based on our divisibility rules, 2 nor any other even number, be it 4, 6, 8, or 10, can divide into the odd numbers. So, at that point, we would want to consider our first odd number as a possible divisibility value, which is 3. So we want to see if 3 can divide into both 6 and 15, and indeed it can. So we can divide both numbers by 3, and 3 goes into 6 twice, and 3 goes into 15 5 times. So 6/15 can be reduced to 2/5. Now for our final example, we have 8 and 40. Now obviously, the ability to reduce fractions in one step comes down to our divisibility knowledge. This fraction could be reduced in one step if we wanted to divide both values by 8. So if I divided this by 8, I would get 1, and divide 40 by 8, I would get 5. Now, some students may not feel that they're strong at dividing, so I will show a second way that we could go about doing this. Knowing that 8 and 40 are both even numbers, we know that we could divide by 2. So half of 8 would be 4, and half of 40 would simply be 20. At this point, 4 and 20 are both still even numbers, so we could divide by 2 yet again. Half of 4 would be 2, half of 20 would be 10. And yet again, the values 2 and 10 are both even, and we could divide by 2 one more time. 2 divided by 2 is 1, and 10 divided by 2 is 5. And as we see, we were still able to arrive at the value of 1/5. It just required a few more steps. Well, I hope these tips have helped. Aside from this, there's some problem-solving applications, but if you have the foundation of these skills, the problem-solving should be no problem. Good luck tomorrow, and we'll see you then.